This problem, when I assess the variables to figure out which gas law to use, has temperature, pressure, and volume. I read through the problem and confirm that I don't have any moles being asked about. I've got 0 degrees and 1 atmosphere and 30 milliliters, and if the temperature is increased to 30 degrees and the entire sample is transferred to a 20 ml container, what will the pressure be? To do this equation, I'm going to use the combined gas law. The combined gas law uses P times V over T equals my new pressure times my new volume over my new temperature. So when I start the problem, my initial pressure is 1 atmosphere. My initial volume is 30 milliliters. My initial temperature is 0 degrees Celsius. 0 degrees Celsius must be converted to Kelvin to do the problem. Remember, if you have C, add 273. So 0 plus 273, of course, is 273. Then my final pressure, that's what I'm being asked, what will the pressure be? Therefore, that's my X. And then my final volume is 30 milliliters. Oh, I apologize, 20 milliliters. That was my initial volume. And my final temperature is 30 degrees Celsius. Of course, 30 degrees Celsius, we have to use if you have C at 273. Makes me 303. So when I set up my equation, it looks like this. 1 atmosphere times 30 milliliters over 273 equals, I don't know, times 20 liters over 303. This is a large cross multiply and divide problem. 1 times 30 times 303 equals 20 times 273x. So I'll have to isolate my variable. When I solve this problem, you should end up with 1.66 atmospheres. I'm going to show you quickly what the problem will look like when I cross multiply. When I cross multiply, I should have 1 times 30 times 303, and that's going to equal 20 times 273 times x. My equation will look like this, and that's when I have to isolate my variable x. What's keeping x from being alone? Well, 20 times 273 is. So I would divide both sides by 20 times 273. These would cancel out. And I would just have x left on this side. On this side, it's very important to remember that when I do this multiplication problem, my 20 times 273, since there are two things under the divide sign, that has to be in parentheses. So please be sure to do that to ensure you get the 1.66 atmospheres answer.